Congratulations, you've made it to question 10 of the Spicy 100. Every 10th question is a special question. They're particularly spicy, and we have a special chili for each one, so check out this bad boy. What a magnificent specimen. The recommended time for this one is 7 minutes. I'll read it to you. Solve the equation, open bracket, 3x squared subtract x subtract 1, close bracket, to the power of 16 subtract 9x squared is equal to 1. Now I'll give you a bit of a clue. There are quite a few solutions here. So there's lots of solutions. I'm not going to tell you exactly how many, but you're going to have to be finding a few solutions here. So if you're feeling confident, pause the video and best of luck with question 10. So this is an indices question, and we also have some quadratic expressions involved as well, so we're going to need to think about those. So the first thing I think of when I look at this is that we have something to the power of something, and that is equal to 1. So I know that that happens when the power is 0. So a to the power of 0 is 1. Is this always true? There is one slightly strange exception, is that 0 to the power of 0, or 0 to the power of 0 is undefined. It's a bit of a weird expression. So most of the time, anything to the power of 0 is 1. So let's apply that. So if we make the power 0, so 16 subtract 9x squared would be equal to 0. Now I like factorizing, and there's a difference of two squares, so we'll get 4 plus 3x multiplied by 4 minus 3x is equal to 0. So 4 plus 3x would be equal to 0. So move the 4 over, divide by 3, so we get x equals negative 4 over 3. And here we'll do the same thing. I'm just going to move the 3x over. And so we get x is equal to positive 4 over 3. So we found two solutions already. Are there some more? So looking at this equation, think how else could we have something to the power of something being equal to 1? Well, we know that 1 to the power of anything will give us 1. So for example, 1 to the power of 0 is 1. 1 to the power of 1 is 1. 1 to the power of a billion is still 1 because you're doing 1 multiplied by itself. Lots of times you're still going to get 1. So if we apply that, we can say that 3x squared subtract x subtract 1, if we make it equal to 1, we can generate another equation and we can solve. So it's a quadratic, so we're going to get 3x squared subtract x subtract 2 equals 0. Now let's just factorize this, so we get 3x. So if we did 3 times negative 1 and 1 times negative 2, then we would get 3x squared subtract 3x plus 2x subtract 2, so that works. So 3x plus 2 equals 0. So x equals negative 2 over 3. And then from this one we get x equals positive 1. So we've got two more solutions. So there is another way that we could end up with 1. If you have negative 1 to the power of 0, that would be still 1. Negative 1 to the power of 1 would be negative 1. But then negative 1 squared would give you 1. Multiply again, so cubed would be negative again, but then if you had negative 1 to the power of 4, because of our double negatives, we'd end up back at 1. So this means then that actually, if we make our quadratic expression equal to negative 1, as long as we've got an even power, it would still give us this 1 that we want. So this implies that if we equate 3x squared subtract x subtract 1 to negative 1 and solve this, we'll maybe find some more solutions. So another quadratic to deal with. So this is lots of quadratics in this question. So that minus 1 plus 1 so equals 0. So it's a nice one to factorize, take out an x. So we get 3x subtract 1 equals 0. And so we'd get x equals 0 and x equals, so 3x subtract 1 is equal to 0. Move the 1 over, we get a third. Now we just need to double check. So if I put 0 into my power here, I can see that 16 subtract 9 times 0 squared is just going to be 16. So for this one, I'd end up with negative 1 to the power of 16. So that will give us a positive 1. If I put a third in, so 9 times a third squared, so a third squared is a ninth, 9 times a ninth is 1, 16 subtract 1 is 15. So for this one, I'd get negative 1 to the power of 15, which would be a negative because it's an odd power. So actually, we're going to discount this solution. So we found 5 solutions. So let's compile all these 5 solutions together. We'll do it in ascending numerical order. So we're going to get x equals negative 4 over 3, negative 2 over 3, 0, 1, and 4 over 3. So well done if you got all 5 solutions there. So I hope you enjoyed question 10. I think that was a particularly spicy one. And if you're enjoying the Spicy 100, do like and subscribe the Hench Maths channel. If you're feeling ready, why don't you have a go at question 11?